and the urban economics, but he also has some work on labor economics. So he's providing a broad overview. And I'm very happy to have Rodrigo here because we are sharing a seminar, in the sense that I'm going to have the seminar to the University of Chile, the Universidad Mayor of Chile. And this is a potential possibility for matching our expertise or for contribute and for starting cooperation among our institution. And I would like to thank you, Rodrigo, but also Ignacio Fernandez, that is the other co-author. So I would like to thank you very much for this workshop and for this seminar. So the floor, Rodrigo, is yours. Whenever you want, you can start with your presentation.
Okay, I'm gonna start sharing my screen. I think you should be able to see it now.
Yeah.
Okay. So yeah, well, let me start thanking you for inviting us. Okay, and this is a more than a paper. This is a project we've been working on, mainly with Ignacio, but also with some other co-authors and students in Universidad Mayor. We started this project, I think around 1 or 2 years ago, with just the idea, and then it became like its own thing, I would say, its own monster, and now it has become like probably the most important part of my work in terms of publication. So we have I'll show you, but we have one paper out, the other paper should be out pretty soon, and the third one around the same topics I'm saying should be also out very soon after we send the revisions. And so thank you very much for inviting us. This is a great opportunity, I think, for us to present what we are doing, to learn from your experience, and also to as Marco was saying, and we're very grateful to hear that, to also invite you guys to present at our seminars and hopefully start a collaboration process among the centers. So yeah, super excited. Been to L'Aquila before. Have great memories from for my 2 weeks, I think I was there, and I met some of you. I'm seeing Julia Urso. I think I saw her during that time. So probably some others of you as well. So yeah, I'm gonna start with the presentation. What we are doing here. Okay, this is the main title of the presentation. The unequal distribution of ecosystem services. And their impacts over socio-emotional and academic outcomes of school-age children. And we are focusing on the case of Santiago, Chile. We are now expanding this to other cities within Chile. But at the moment, what I'm going to present are just results for the case of Santiago. I need to be very upfront here, as Marco was mentioning. Despite the fact that I'm a geographer originally, and then my whole career has been on economics. So my focus is on economics and methods and the quantitative part of the portion of the papers. And that's why Ignacio is so important here, because he's the expert on ecology, the differences between ecosystem services and all that. So he's probably gonna correct me on most of these topics.
We can talk about that later at the end of the presentation.
Yeah, I know that's gonna come at the end. You shouldn't have said that. But anyway, so I apologize in advance for the loose use of some of the terms, I guess. Oh, and one question that I have for the audience is or maybe for Marco, it's like this is mostly people in economics, or this is like multidisciplinary group of people here, just to see what you guys are more interested in.
Yeah, you can think about a multidisciplinary environment, okay, because we have mixed students that have a different backgrounds, from geography to economics. So even the audience could be mixed in some sense, and this is one of our favorite topics, the one that are multidisciplinary and that match different fields. So this is our group in some sense.
Okay, no, perfect. We work again. We also work in a broad disciplinary field. So this is perfect. I was just asking because in the case if it was just economics, economist here, and then I would have to go deep into the methods and specifically about the identification process and all that. If not, we can just talk like normal people, I guess. So
I think that someone that is with a background in economics could ask you something about the meters if they would like to know something more. So this is
sure.
Another option.
Yeah, that's perfect. And also please feel free to interrupt at any moment. It's not a problem. So if you guys feel like doing that or waiting until the end, whatever you feel comfortable with. So let me start with a little introduction on how we came up with the idea. Of course, we are not the first of looking at this topic, so we are building on previous evidence here. But what do we have here is Chilean cities being among the most polluted in the world. So we start with this pollution part section, I guess, of the idea, and then we started developing more and more and adding more environmental aspects to the mix. So, but we start with that. We have very polluted cities for different reasons, very different pollutants, I will say, in different parts of the country. And also we have a high level of segregation and inequality in terms of also in several aspects, socioeconomical aspects, but also then I'll mention also in terms of the school system and also as well in environmental quality. So we will have differences in terms of, for instance, access to green areas or greening or vegetation cover, depending on where you are in the city, and that's going to be correlated with your income. So that's going to be one issue that we're going to be trying to solve later in the paper. But we start from that. And so we know that there is some evidence pointing to the effects of the environment or this environmental aspects on productivity and also on quality of life. And I'm just mentioning here for pollution, for instance, we have for productivity, we have a couple of papers, also in academic performance, development. There is one study we found for Chile, but we think our study is better, and I'll tell you why. Then we have green cover having effects on health in general and different aspects of health, but also on cognitive development and academic performance. Though the evidence there, I'll say it's not necessarily robust, and so we have some mixed evidence of positive effects, negative effects, no effects at all. So it's kind of like all over the place still, and there's not enough evidence also. So the few papers that are around on these topics are in general new with different results and not very many. So so it's an ongoing discussion, I guess. Similar results we're going to find for noise, although we're not going to explore that. I'm just mentioning there are several different aspects of an environmental quality that can affect your productivity if you're a worker, or your academic performance if you're a student, and also your quality of life in general. So that could have effects on different other aspects of your life. So as I was saying, whereas there are some papers trying to look at this issue, there is little or no evidence on combined effects, and that was the starting point. It was like, let's see if we can put all this together and try to see what is the temperature or maybe the pollution or the green areas. It's a mix of all of them. What can we say about the whole a couple of environmental aspects that can affect academic development and academic performance and development. So that's one thing. We don't have many papers on this aggregated aspects. And also for the Chilean case, we found one paper trying to do this, which is actually not a paper. It's a document for the IADB produced by Miller and Vela in 2013, and they do something similar. They try to compare the outcomes in terms of academic performance of the students in Chile, correlating that with pollution, but they use like annual pollution, like the aggregated pollution, and it's not very clear what they did there, because we only have a couple of stations monitoring pollution, so it's not very clear what they did there. But anyway, that's the first evidence. What they found is something similar that what we found. It's a negative effect of pollution on outcomes, which is something we expect. And again, Santiago is a particular case, we think. It's highly segregated in several aspects, as I was mentioning, and also highly polluted. So, and this segregation, it's not only socioeconomical, it's also regarding this environmental aspect. So I'll show some maps later to make it more interesting, and you'll see how this is distributed across the city. So we started this project, and we are now in these 3 papers. 2 of them are already out in a way. The first one, it's supposed to be out. We haven't seen the actual publication, but it's something that IADB produced for a project called Chile Out of the Box. They call a bunch of academics. They made a grant. They provided a grant for the study, and then they were supposed to get these results out. Our paper was accepted, I would say a year ago, maybe, Ignacio, I don't know, maybe a year ago. And so this was supposed to be out in October last year. And then we lose track of what's going on there. But that's supposed to be out soon. Oh, my cat is attacking me. Then the second paper is a paper that Fernandez, like Ignacio here, was the main author, the principal author, about trying to see how the vegetation cover within schools and around schools, it's correlated or not, and whether schools are doing something to mitigate or like trying to reduce the urban vegetation inequalities. And then I'll show some results of that. That's already published. That was published, I think, like a month ago or so. And then we have a third paper that we're working on, and we are in the second round of revisions about the green cover and the effects of green cover on socio-emotional and academic outcomes, all for Santiago. So our main goal with this presentation, I'll say, that we had in the beginning, it was we wanted to evaluate whether this environmental aspects, and I'm saying ecosystem services there with an apostrophe because I'm not completely sure, Ignacio is going to correct me on that, have an effect over academic performance. So that was the starting point. And so in a first paper, and this is the first results that I'm going to show, we're going to focus on pollution, a green cover as a whole, everything that is part of vegetation, I would say, and temperature. That's going to be the 3 aspects that we're going to look at. And for the case of green cover, we're going to introduce some novelty, I guess. We're going to look at the green cover and temperature inside and around schools. So especially for green cover, that is true. And so we're going to be able to actually map the schools and see how much of the school area it's vegetated, and also do the same for buffers around the schools. We're going to take all schools in the urban area of Santiago, and we're going to use for this tests, standardized tests of math and reading for 4th graders. This is a national assessment. We're just going to use Santiago, but this is a national assessment. You can compare with between schools, between cities. So that's the beauty of it. It also has some drawbacks that we can talk about later. And
Rodrigo?
we're going to use the, yep, Ignacio.
Yeah, just a small correction for the third line that you have there is that we really don't measure temperature inside the schools. For that specific variables, we have the temperature around the schools, and here in Chile, we don't have air conditioning or whatever during summer, so the temperature that is outside is mostly the same that you have inside because all of the windows will be open. So just to make that point.
Yeah, thank you, yeah. And so we're going to use the period 2010 to 18. And so that's going to be our first paper. And then we're going to be adding, for instance, we're going to try to see whether we have differences and some heterogeneity depending on the vegetation type that we found. And so is it the same to have, how do you call a caduceus tree? The tree that loses its leaves? Is that the right word? Or evergreen vegetation or grass? Is it the same for all of them? So we're gonna try to explore that potential heterogeneity in results. We're gonna also add other higher grades, school grades. So we're not just gonna be looking at 4th grade, but also 6th grade, 8th grade, and 10th grade to see if there are differences there. And also we're gonna add this, what they call now personal and social development indexes. So not only on academic performance, but also in terms of some social and personal development, which to me is it's more important in the long run. So I think that should be the focus. But anyway, so okay, let me for the economists in the audience, especially, what some of the problems we're going to face here. It's a more environmental. Most of the environmental aspects are observable. So when you're trying to estimate this association, what you're going to find is probably some sort of bias. So if students or students' parents can actually choose the school, they can also choose whether they want or they value vegetation, for instance, or less polluted areas, or better temperatures, or whatever. And like, so if they can actually choose, then this can introduce some sort of bias in the process. I guess I'm not going to discuss that as much, but I'll just say that they cannot really choose in the case of Santiago, and we're going to show what's going on. Only students of families of high income can actually choose what they want. Then we have a highly segregated city again, but also the most important thing here is, like, we have some spatial coincidence in terms of academic results, income, and environmental aspects. So all of them and more are all correlated in space. They're all located. Students with better academic performance are located in places of higher income families, but also they will have better access to, for instance, greening in vegetated areas. So you're going to have that coincidence there, and it's going to be difficult for you to try to isolate the effects. So what we're going to try to do here for the first paper is going to try to focus on pollution. And the reason for that, I'm going to explain it in a couple of slides after. It's that we can track the pollution at the time of the test. And we believe that is exogenous. So we can say you can anticipate polluted areas in general, but you cannot anticipate how polluted will be the area of your school at the time of the test for the day of the test. So that's kind of like an exogenous shock. You can think of this as having random fires across the city. And so some areas we're going to have a fire, some other areas will not. And I'll show that this changes from day to day. So it's very unlikely that parents and students can anticipate this. So that's the basic identification we're using here. So this is, I don't know how familiar you guys are with Santiago. but this is basically, well, the map of the urban area of Santiago. This is how it looks. And so you will see, we have here 4 variables, and then I'll show more. Temperature, vegetation cover, air pollution, and the socioeconomic level of families. And what you're gonna see is richer people, more affluent people will live in the northeast part of the city. Generally, those areas are also less polluted, and again, they have more vegetation, and also they suffer less from high temperatures. So that's the coincidence that I was mentioning. So again, how are we going to separate these environmental aspects from others of income, education, education quality, self-selection, etc.? What we're going to do is use controls for income and others, but also we're going to add school fixed effects. And for those of you familiar with fixed effects, what we're doing here is basically adding a specific constant to each specific school, basically running a regression for each specific school. So then the variation comes, or the identification comes from variation within each school. So this is basically saying only variations in pollution within the school, we're going to have an effect on your scores. So this is asking a lot more from the data, but also at the same time is trying to isolate the other effects that I could be impacting the results. Then the other 2 risks we face is maybe we're going to have little spatial variation in environmental aspects, and we're going to show that's not the case. And already you saw some of that. We have more or different environmental aspects or quality in different parts of the city. So that's not as an issue as we thought it could be. And then, or as I thought, I guess Ignacio already knew this. And then, but this is more like a risk here. We could have a little time variation on average environmental aspects over years. So this is a problem when you use, for instance, and this is the critique that I have for the Miller and Vela paper for Chile, when you use the average pollution level of a school, of a municipality, of an area, that's basically like a fixed effect, because areas that are more polluted will continue to be more polluted over time, and areas that are less polluted will continue to be less polluted over time. So there is little variation there. So I'm not exactly sure what you're identifying when doing something like that. So that's why we thought we needed to come with an idea of trying to explicitly exploit time constraint variation for some characteristics, and that's what we face, what we do for pollution. So that's basically what we're doing. In terms of methods, very simple here, just a regular regression, nothing complicated. Our dependent variable will be the math or the reading score in the first paper, and our independent variable of interest will be pollution or others. And I'll show the results for all of that. And we're going to add some municipality and school level controls and year dummies. I already mentioned some of the endogeneity problems, but I'll be happy to come back to that if you guys want to. The only other thing that I need to mention, I guess, or stress more is the fact that we are using the pollution levels at the time of the test, the day of the test, for each specific test. So we're going to say, all right, we're going to measure the pollution between 9 and 11 a.m. the day of the test for that specific test, which is different from that of the next day, and I'll show you some of that. So in that way, we think we have some random movements of pollution, and that provide us with our identification. In terms of the data, for most of our research, we only have 10 stations for pollution and temperature. What we're going to do is to interpolate for schools. So the schools will be located in between these stations. And so what we're going to do is create like a map trying to interpolate the measures we have for pollution and temperature to give some idea of what's probably happening at the school level. And so then we're going to do some robustness there. But that's basically what we're doing. And so that's, in fact, why we focus on the urban areas of the cities, because we have more information for them. And it's going to be harder and harder to try to guess the pollution levels or temperature for areas that are far away from the stations. That's also why we are going to first run regressions for the whole city, and then we're going to say, all right, we're going to just estimate regressions for the schools that are closer to the stations. So probably we have a better estimation of their pollution and temperature than from others that are far away. So we're going to do that for robustness. We're going to be using particulate material 2.5 and 10, satellite images for green cover. We're going to be constructing NDVI and SABI indexes, and then Ignacio can explain more of that. And we're going to build some vegetation buffers around schools to see whether the neighborhood, the closer area, or the whole municipality are affecting also the results, and to control for that. And we're going to be using the math and reading scores from 2010 to 2018. So we have around 1,200 schools for 7 years, around 8,000 more observations. So before going into the results, let me show you this. This is a map. On the left of your screen, you'll have a map of the schools where they are located. So basically, we have schools all over the place within the city. And then on the right side, what you're gonna see is on the top panel, panels A and B, you're gonna see the annual average of pollution in Santiago. And then on the right side of the upper panel, you'll see the pollution between May and August for the year 2015. This is just to pick one year. And basically what you're seeing here is like it's more polluted towards the west of the city, probably the north and west of the city, and less polluted towards the south and the north and eastern parts of the city. But then this is where it gets interesting, I'll say. When you look at the lower panels and panels C and D, for just 1 day of difference between, for the same year, 2015, day 1 and day 2 of the test, you're going to observe differences in terms of the behavior of pollution. In the first day, you're going to see more pollution in the northeastern part of the city, whereas in the second day, you're not going to see that. So then here's this is the like kind of like what we call the randomness of the pollution for a specific moment of the time. This is for the time of the test, for the days of the test. So you will see differences. So when you look at the aggregate pollution, you're not going to find many differences. But when you look at specific moments in times, then you will see some differences. That's our assumption there. This is temperature for day 1 and day 2, and it is also true that you'll find some. Whereas the trend remains the same for both days. The second day was hotter, and so then you'll have some differences in terms of temperatures across the city for just 1 day of difference. So that could also add some variation to the mix and help getting the results. Then we're going to see temperatures are not. We don't find effects for temperature, but it's still it was something that we needed to test. So all right, now I'm going to move to the main results of the paper. And I apologize for the table. It's not very, I guess, very pretty. But let me just say this: we are going to focus on the particulate material 2.5 between 9 and 11 a.m., which is the first row on the top of the table. And then we have OLS estimates and then fixed effects estimates for both math and reading. And I'll keep my comments to the fixed effects models, because for the reasons I already gave. And so when you look at that, we found no effect for reading in terms of pollution being a factor decreasing scores. We do found a negative effect for reading, but it's not significant. We do find a negative and significant effect for math, both in the OLS regression and also in the fixed effects regression. So that provides us some confidence that we are getting what we think we're looking at. And so those coefficients by itself say very little, but in terms of like, how do you explain this? This is basically 2 points in any given year, the difference between schools, poor schools and richer schools. And this is also 4 points of difference in the heavily polluted years. So when you have a heavily polluted year, your scores could be reduced by 4 points in a scale of like 250 to 300. So it's like 50 points of difference in between the minimum and the maximum. And so basically you're going to have either 4 points more or 4 points less, just because of the pollution at the time of the test, which we think it's a very interesting result. And so to put this in context, this would explain around 4 to 5% of the gap between rich and poor schools in Santiago. So between around 5% of the gap that we found in terms of scores is explained only by the pollution that you faced that day of the test. So that's regarding pollution. As I was saying, we're going to try to see whether we found results also for other aspects. Here's vegetation within schools. And we found a positive and significant effect for both the OLS and fixed effects models, and also for math and reading. So basically what we are saying here is more vegetation will increase your scores by around 15 to 10 points, which is highly significant in any given year. And well, the other variables are there. I'm not going to mention them, but we can talk about them if you guys want to. Let me just say for now, vegetation will be very important in increasing the academic performance of students, and way more important than pollution of what we can see here. If we take these results as given, then we'll have to say that vegetation is way more effective in terms of increasing test scores than pollution. At least pollution at the time of the test. And there, I stress that because there is a difference between pollution at the time of the test and the accumulated contamination or pollution that you will face over your entire life, that we are not measuring that. So this is very important to keep in mind. Probably if you're facing, you're living in a heavily polluted area for years and years, that will affect your cognitive development and academic performance, but we are not capable of observing that for now. Then we're looking at vegetation in the surroundings of schools, and we again find a positive and significant effects for math, and positive but not significant for reading, at least not in the case of the fixed effects model. The magnitude of the coefficients are similar to the ones we found for vegetation within schools, and that has an explanation, and we're going to show that in the next couple of slides. But basically around 14 points of increase in terms of scores. But, well, this raises the question of whether the schools and the vegetation within schools and the vegetation in the surroundings are correlated between them. And some of that is going to show up in the next slides. This is for temperature, and here we found positive effects for reading and negative for math, but both are not significant. So basically 0. We are not able to find any effect for temperature. I believe there is not enough variation here to actually capture the effect. It's not that there is no effect, but we are not able to identify it. I think we don't have, again, a good identification strategy for temperature, as I think we do have for pollution. So yeah, basically no effects. And here we're putting all this together. So running a regression with all of this together at the same time. Again, OLS, fixed effects for math and for reading. And here again, the effect of, let's just focus on math for a minute. And for the fixed effects model, pollution at the time of the test is going to be negative and significant. So it's going to reduce your test scores. Vegetation within schools, it's going to be, again, positive and significant, and the score for both math and reading is around 11 points of increase. And interestingly, vegetation in the surroundings of the schools seems to be not important when you include the vegetation within schools. This is very important because not only because it's showing you that probably both variables are capturing the same, but also because it gives the authorities of the school the ability to change the quality of life conditions of their students without regards of what's going on outside. So vegetation within school will be more important than the one outside of schools, and that makes sense in terms of and the theory that there is behind this. Again, temperature's not showing anything, so nothing to say about temperature, I guess. And for reading, we have not a lot of variation. Only for vegetation within schools, we again find this positive and significant effect. Final tables of this paper, and then I'll show some graphs. I told you we are interpolating from 10 stations, which is not a lot. We have more than 1,200 schools, and we have only 10 stations monitoring pollution and temperatures. So let's say we don't trust our interpolation method. And so now we want to just keep the schools that are close to the stations, so we are more confident of what they are saying in the results that we are getting there. And we still find the same, but the magnitudes of the outcomes are larger, I would say. Nothing for vegetation outside of school, nothing. I guess we now do find something for temperature, for math. And so now when you increase temperature, math scores are reduced. And this is very important because, as I was saying, in the first part of the portion of the paper, I was saying, it's not that I don't think there is an effect. I think we are not able to identify it. Here, we are getting closer to that. So now we're saying, all right, there is an effect. It's negative, as we thought, and it is significant for the case of math. And also for the case of pollution, the same as we had before, negative and significant, and the magnitudes are larger now. And that was on the left side of the screen, and on the right side, we say, all right, let's see, this is a coincidence. Let's say this is a coincidence, and we're just like getting whatever from the regressions. Let's run again the regressions of pollution, but let's change the days. Let's put the pollution of the day 2 in the test taken on the days 1, and the pollution of day 1 on the test scores in day 2. Those has to be not correlated by definition because those are different days. So if we still find an effect here, it's because we're doing something wrong. And luckily, we didn't find anything here. So no effects for pollution when we do the placebo test, which again brings confidence to our initial results. So I think we're getting the pollution part at least right. And I think the temperature, we're getting closer to it when we explore the schools that are closer to the stations. So that's enough with tables. I think I'm not going to show any other tables. Then we and I don't know how I'm doing in time. I think I have 5 more minutes, maybe. I'm gonna try
yes,
to.
Rodrigo, more or less. If you need some time, so you can have even extra time. Don't worry.
Okay. Yeah, no, I think it's. I'm gonna be fine in maybe 5 or 10 minutes. So then we do a follow-up manuscript. And again, in the results that I just showed, vegetation was very important, and so we decided to explore more on that. But also we had information on different types of vegetation. So we were saying, all right, we're going to use the same method, we're going to use the same schools in Santiago, but now we're going to differentiate between vegetation types, and also we're going to expand to 6th, 8th, and 10th grade, in addition to the 4th graders that we were looking at in the first paper, to see if there is variation there. It could be the case that vegetation would have an effect on some students more than others. I don't have a particular theory for that now, but I think it will be interesting to see whether these effects are different. So this is like an open question. And now we're going to use academic, but also development indicators of personal and social development indicators of the students. And unfortunately, now we're just going to have to use year 2016. We are trying to expand that in the next couple of years, especially if we get the grant for this, because we have the classification of vegetation types for that year. So we're going to use that year. And so this is a cross section, but we have different grades and vegetation types. So this is a map of where the schools are. Again, schools everywhere. And here we're doing something different. We're looking at whether they are private schools, subsidized schools, or public schools, which again is something new. And on the right part of the map, you'll see how we, and we say, when I say we, it's basically Ignacio, construct this polygons of schools, and then how we compare that to the vegetation in the same place, and we put all that together. This is what we're doing, and again, you will see more vegetated areas in the northeastern part of the city. And so now I'm graphing our results, and I'm not going to show again all the method and all of that because I already did, and it's basically the same thing here. On the left side of the screen, we have the effects of green cover over test scores for math in blue. I mean, for math in red and in reading in blue, and we found basically no effect. I mean, for the case of math, we do find an effect that is positive, but it's not statistically significant. So basically, we are not able to identify this again. When we move to personal and social development outcomes, we do found an effect. And so now we're getting to something different. So socioemotional indicators, broadly defined, are correlated with the green cover that is within the school. It particularly in all cases is positive, but it's highly significant for the case of school coexistence and also civic participation. We get a positive effect in some of the regressions for self-esteem and also for healthy life habits. But this is the general result we get. And then, as I was saying, we're going to look at this for different school grades. So this is for 8th grade, for instance, and I'm not going to bore you with all the graphs, but this is for 8th grade, just to show you that there is you have the general results. And then when you look into different groups of the population or the students, you will find different results. So for instance, in the left part, you will see for green cover as a whole in 8th grade over social-emotional outcomes, and then you find a positive for everyone and highly significant for 3 of the 4 social-emotional indicators. So again, green cover being very important in providing some sort of development and stability and emotional comfort to students. On the right side, we took a step forward again And then we say, all right, let's see how this works when we, instead of looking at the whole vegetation, I'm sorry, my cat is here. We take only evergreen trees, and let's see if we dare find more of an effect, and then we do. And so now everything is significant, everything is positive for the 4 indicators that we have at hand. Self-esteem and motivation, that's the actual name of that. Healthy life habits, school coexistence, civic participation, all of them are positively correlated with evergreen trees. So the more you have of those in your school, the better the socio-emotional outcomes you will have in your students. And I guess I lied. There is one more table. One important thing about this is that we do not find an effect of green cover on reading and math scores directly for any of the regressions. I could show you hundreds of tables and we don't find that effect here. But here there is a difference with the paper that I showed you at the beginning. Here we're controlling for school coexistence, self-esteem, healthy life habits, civic participation. We're controlling for all that, and almost all of them are positively correlated with the scores. So we think here, and we proved it in one of the tables that I don't have here to show that there is an indirect channel by which green cover is associated with socio-emotional indicators, and those socio-emotional indicators are associated with test scores. So that's basically the mechanism here. It's not direct, or at least we are not able to identify that, but it's through the socio-emotional indicators that we are finding this effect. And I apologize, I didn't bring that table. We did it for one of the robustness checks that we did at the end of this project, and we did find that. I should have brought that. Let me just finish with the, weirdly enough, I'm gonna finish with the actually published paper, which is the one that Ignacio led. And so now let me just show you the distribution of schools. Again, we're looking here at private schools, subsidized schools, private, subsidized, and public schools. Private schools, of course, are located in the Northeast area. Mostly, but also you can see again, poverty rate is lower there, vegetation is higher there, build cover is lower there. So again, they have the best conditions in the city. They have more money. They have private schools that tend to or supposed to be better, and so it's several injustices, I will say, unfairness in the distribution of assets. And so then, which schools have more vegetation within them? Private schools, by far, are way more vegetated than other schools. And if you look at what's interesting about the graph on top, is if you look at within schools, the differences is not as marked as it is when you look at vegetation in the surrounding areas. So the city, it's more unequal, I would say, than its schools, but the trend is the same. So schools that are private, that are located in this part of the city that I just show you, are way more green than public and subsidized schools. And basically, there are no differences between public and subsidized schools, at least in what we can see here. In the bottom, we have a bunch of correlation graphs. And basically what we're saying is there is a highly significant and obvious correlation between the vegetation you have outside your school and the vegetation you have inside your school. This is something that we can talk about in the light of the results showed before. I'm not going to go into detail here. I don't know if Ignacio wants to go here, but basically saying we have a strong correlation between the vegetation outside of schools and inside the schools. And this is showed here, where we basically plot that in the reddish colors. It's a positive association where basically schools are replicating city inequalities. And it's basically when you take all schools in a buffer of 100 meters, it's basically all schools are doing that, except for a couple of whites in between. Basically, the whole city of Santiago, the schools are replicating whatever it is outside the school. So not helping a lot in terms of reducing inequalities. So I'll just finish here. What do we conclude about this research that we are this ongoing? In environmental aspects do matter. Maybe that's not a real contribution. Maybe you already knew this, but I guess it's important to find the results that you're supposed to find. Again, some variables are correlated with where others. So when we include all together, some of them drop in terms of significance. Nevertheless, pollution is very robust and significant for academic performance, especially for math. I should have said that. And greening is very important and for personal and social development, even when controlling for vegetation around schools. And the important part of that is, again, that gives you the light where you should invest the resources in terms of greening. Within green vegetation cover, evergreen vegetation is the most important, is the one that produces the most important results. But we do find heterogeneous results according to the indicator, the school grade, the vegetation type, and so it's not just one size fits all. It's important to keep that in mind. Now we make some questions about the paper, the first paper, I guess. In the case of pollution, we think we're going to get different results if we look at different times of the year. This test that we're using is taking close to the summer, close to the end of the school year, so which is close to the summer. So then pollution is not as high as it is during the year, during the school year. So probably if you have a way to look at this same process for the school year, you're gonna have way more significant and more important results that what we are able to find here close to the summer when there is not a lot of pollution. So the fact that we still find it, it sheds some light on the fact that that probably the effect is even bigger than what we can compute here. We could also expand this study to other cities, more polluted cities. We have highly polluted cities in the south of Chile. So we should expand to that. And also it's a different type of pollution. So maybe there is a difference there as well. There are differences in terms of vegetation. In the north part of the country, we have less vegetated areas in general because it's drier. And we have more vegetation for the south. So there are probably differences there that again are exogenous to students. And here I'm going to finish. Next steps for us, and this is basically to show Marco and the team here, what are we working on now and where do we want to move on to? Well, first of all, we think there is a lot more to study. We think we're just finding like or getting results from a small portion of the actual results that we can get here. What we are trying to do is getting some grants from the Chilean government. So we want to include more cities, more years, different topics. But we think this whole environmental aspects in academic performance and socio-emotional indicators, it's a hot topic. So we're going to keep working on that. There is some idea of looking at how do we measure the actual contact that students have with green areas or with green cover. And one of them could be looking at this school farming or I don't know if there's the actual concept for this, but like when you have this, you show students how to have some farming activities within the school. How will that affect their outcomes? There is a difference between green areas and greening. I had a lot of discussions with this about with Ignacio about this. But I think green areas, despite the fact that they don't provide necessarily greening, they could also play a role in terms of like providing places to I don't know, hang out with your classmates and like relax, I guess. So there could be something there that we are not exploring here. We're just exploring the greening part, the vegetation part. And again, we are using what we have at hand. So we think we could construct better measures of school performance. We're now just using what we have, and also development. These are indicators that are coming from the national government. And we don't have what it is inside them, so we cannot actually construct our own indexes. We need to use what they do. Finally, from identification purposes, if we could follow students to know where they live and where they go to school, that will be much, and we can follow them through years. That will be a much better way to identify the effects that we think we found here. So I'll stop there. I'll be happy to. I don't know if Ignacio wants to add something, or if we just wait for the comments. Thank you.
No, I'm gonna wait for the comments and questions that people may have.
Okay, so
and I'm gonna stop sharing.
Yes, thank you, Rodrigo, for this very interesting presentation. Thank you, Ignacio, for the work. And for presenting some projects, not only one paper. So it is interesting. So we are used here to give the floor to younger scholars and even PhD students, so they can break the ice if they want. I don't know if there are questions from the audience.
I will be happy also to answer any question regarding to the technical issues or technical methods that we use for generating all the information that Rodrigo showed there in the graphs.
Yes, this is very, very interesting. Actually, I have some comments or questions. So there is Carlo, no? So it's Carlo is one of our PhD students. So he has priority. So go ahead, Carlo, please.
Okay, thank you, Marco. Rodrigo, Ignacio, thank you very much for this very interesting presentation. The topic, of course, is super interesting, even if super complicated to be addressed. My question is simple, and I would like to know if you are able to account whether a student, or let's say a percentage of students within a school do live in a different district with respect at the school itself. Since you said that Santiago is a very segregated city, maybe this percentage is not so high, I would expect, but probably it would be an interesting stuff to consider. Thank you very much again.
Thank you, Marco. Let me know if you want us to answer each question individually, or wait for.
I think you can answer each question individually, and then we can move to Alessandro Palma. Okay. There is a question, but you can start, you or Ignacio. It depends. I don't know who would like to reply. But...
Yeah, sure. I can say something about that, and maybe Ignacio also wants to add something to it. Let me just say very briefly, because I already talked a lot. We cannot, with the data we have, we cannot do that. And that's kind of like I mentioned at the beginning, we do have some benefits from using the data we have in terms of like comparing between schools and like it's comparable across years and all that. The drawback we have is that we do have information only at the school level. Even if we do have if we had at the student level, we were not able to identify where they live. We don't have that information. So it is possible for them to live in one municipality and go to a different one at school. But in general, I will say, and maybe Ignacio or Esteban, I'll introduce him in a minute, want us to add something about that, because in general, I will say it wouldn't be the case that they will move from a poor area to go to school in the richer areas. So that wouldn't happen. But what could happen is they could move from a poor area in one part of the city to another different poor area in a different part of the city. So to that extent, I think we are safe with the results we have. But you have a very important point there, and that's what I was mentioning, that we would like to follow students through time, and also in terms of like where do they live and where do they go to school to. I don't know, Ignacio, I already introduced him. He works in the same project with me, and also Esteban has participated in some of the papers with us, and so he's an expert on education. So I don't know if one of them wants to say something about this.
Yes,
thank you for the question, Carlo.
Yeah, I know mostly the same that Rodrigo. I know that some students comes from other municipalities, but we can assume that most of the students that attend one school comes from the surrounding areas. In fact, there is a paper that they did. I don't know exactly how they did that, but they tried to measure this, and they say that in urban areas, most of the students comes from around, I don't know, 1 kilometers, whereas in the rural areas, they came from, I don't know, 10 kilometers, something like that. But in urban areas, at least in Santiago, it seems that the students, at least in most of the public and subsidized school, they come from the surrounding areas. They don't cross the entire city to go from one school to from their homes to the schools. I don't know if Esteban has any other information about this.
Hi, everybody. Not really. Basically, what you mentioned is what we know. That information comes from the student level. Chile has been improving its data quality in education extensively for the past 8 to 5 years. And now we have information from 1990 to these days. So we know certainly that 40% of students that move to a different school, for example, when they are transitioning from primary school to secondary school, which is the moment when most of school changes happen in Chile, are actually to adjacent areas where they live. And usually those areas are very similar in terms of socioeconomic status. And that in Chile means also that you're in a municipality that is very similar to the one next to you. And basically municipalities are the ones running local green areas. And so the constrictions and the limitations for each of those municipalities are very similar. And geographically speaking, you could also see in the maps that Rodrigo already showed that basically that's the situation. I think that's it.
Thank you again to everybody.
Okay, thank you all. So we can move to another question from Alessandro Palma, that is assistant professor at the GSSI. So Alessandro.
Can you hear me, Marco?
Yes, I can.
And can you see me?
Yep.
Because I can't see my face. Oh, okay. Okay.
Thank
you for my position. Actually, I'm not associate professor. Can you see me?
Yeah, but what I said, associate. Come on,
I can hear you, Marco.
You can hear me now. Hey.
Yeah, that's what I got it, but thank you.
Okay, you are almost associate professor.
Thank you very much, Rodrigo. Yeah. So Rodrigo, nice to meet you. This is Alessandro, GSSI faculty. I attended your presentation with great interest, also because this is one of my favorite topics, so I'm happy that we can host today. I have a couple of comments and a couple of questions, not comments, a couple of suggestions to improve the work, and a couple of questions. So first of all, let me ask you if you can disentangle the effect, the net of potential confounding due to air conditioning, basically indoor control environment, which in this topic is very important. As you know, there are famous papers like the one by Josh Zivin and so on, that examine the effects of temperatures and pollution in a more controlled environment. This can make a great difference in your estimates. At least this is what the many papers show. So if you have this information, I strongly suggest to include in your model. And or maybe you have spatial information on school provided with air conditioning versus school without air conditioning and so on. And this is the first comment. The second one is, I was wondering whether you can also disentangle, in this case, the effect between learning and performance, which is basically what you estimate during on the test, which is more performance effect versus an effect due to basically accumulated effects due to learning, and basically, as in the case of performance, learning can be affected as well by pollution over a longer period. So basically, these are, maybe if you have information, I think you have information because you can, you have data, retrospective data on pollution, so you have built your each school's history made by pollution levels in a retrospective way. And what else? Comments? Yeah, this is all about the comments, and a couple of concerns that I have on your design. So first of all, I take the identification based on basically the day of the test, of course. The treatment is orthogonal to each student's characteristics and observables. That's the standard procedure. But I have more concern when you estimate the effect on basically green areas. Because while during the day of the test, you have variation, day by day variation, you don't have this variation on green areas. So basically green areas are something that are place-based, remains constant over time. And basically, while both temporal and geographical avoidance, two important concerns in this setting, are negligible in daily variation. In the case when you estimate the effect on green areas are basically more stable in time, and people can strongly sort into this more greener and more and cleaner areas. And of course, greener areas are much less correlated with pollution areas, and somehow basically might even be reduced pollution in greener areas. So even if you control for, you estimate the effects on green areas, controlling for pollution and vice versa, I think that either two ways, the effect can be biased somehow. And I think that's it. Oh yeah, I'm curious to understand if you have effects on the performance across grades, because I am a similar study, and we find that basically the effect of air temperatures is much smaller in higher grades. So I was wondering whether you found something similar. Thank you.
Yeah, thank you very much, Alessandro. Very interesting questions and comments. I'm just gonna wave my hand to some of them, and some others, I guess I do have a better answer. But again, maybe Ignacio can complement or Esteban. Regarding air conditioning, as far as I'm concerned, I don't think we have that data. Regarding whether schools have or not air conditioning. What we could do, and I was thinking when you asked that question, we could exclude from the regression as a robustness, I would say, the richer areas of the city where the air conditioning will be. If there is if there is air conditioning, that would only happen in richer areas of in private schools, richer areas of the city. So we could, I guess, in a way where we do that, we could exclude private schools, we could exclude richer areas of the city, and see whether we there find an effect, or we there see something different. I think that's very interesting to do, and I think the motivation that you're giving about air conditioning could very well fit that part of the paper. So we haven't done it directly, or we haven't stressed that as much as maybe we have had to do, but I think that's very interesting to do, and I think that will be the only way that we can go around the air conditioning part. In terms of learning versus performance, maybe Esteban want to say something about it. What we can do is just measure performance, which is the test, and there's even some concerns about how comparable are these tests across years for the same school. So it should be in a way comparable, but anyway, it's a complicated process. Again, Esteban maybe want to say something about it. As of now, we're not estimating effects on learning, and I think that's a very good point and very valid. The last two comments were maybe green areas, the effect is not causal. And yes, there is something. In fact, we have changed it. Maybe it was subtle, but we moved from the effects of this of pollution on academics to association, because we were aware, and then we were made aware by the reviewers in that paper about the same issue. We believe, since we're using a school fixed effects, and we are looking at the vegetation within the school, only variations in the vegetation within the school will have an effect. That's what we are identifying. And so we are hoping, again, if there is no changes in vegetation, then we will find no effect, because we have no variation to estimate. So there has to be some variation in order to identify that, and we are finding something. So there is some variation within schools, even when we control for the vegetation outside. So that gave us some sort of relief to that extent. But again, probably the only way to do what you are thinking, and I think, and we have thought of this, it's probably maybe do like a pre and post measure of academic performance and social and personal development in a poor area, say, where it gets a park constructed. And we have one example of that, a very good example, I think, and I've been willing to work on that in the case of Santiago. And I think that could provide us with more like an identifying effect. And finally, regarding effects across grades, we do that for the vegetation paper. We didn't do it for the pollution paper because we wanted to have the full. The problem we have is, like, for fourth grade, they measure the test every year, but the other grades are changing. So some years is sixth grade, some others is eighth grade, some others is 10th grade. But the only one that is constant through time is fourth grade. So that's why we keep that. And for pollution, we have more years and we have more variation. For the cross section for 2016, we do have those 4 levels that I was mentioning, but we do only for vegetation, not for pollution. But that will be very interesting. I don't know. Esteban apparently wants to add something, and then maybe Ignacio wants to add something else. Thank you for the very, very interesting questions and comments.
Thank you, Rodrigo. Just about the learning portion of what you described. So the SIMSA, which is a national standardized quality of education system that we have in Chile, it is the measurements are very stable since 2006 and on. Some of the nature of the questions that we have there and some of the abilities that we're measuring there changed a little bit in 2008, 2006, if I'm correct. That's one thing. That definitely performance is not the same as talking about learning. And if we're going to talk about learning, in my opinion, we should have also a better idea about how the green areas are used and in a way are enacted as part of the educational process and the learning and the teaching learning process. That information we don't have. The only way to do it would be to go and do a specific data collection process. That's one thing. Also, I think we could probably check for a different paper or check with Rodrigo and Ignacio. Chile has information about student retention, which is a measure of how much the student learns that in the end they have to either repeat or withdraw because they struggle with persisting in school. And part of it relates directly with academic performance and a consistent academic performance, right? So that could be a way to measure using a different type of outcome and see if there are any impacts in it. We also can find in Chile information about different fields and the performance of those students in different fields throughout the year. So we could probably check on those, but those were not part of our original design. And thank you so much for the questions. I don't know if there's any lingering aspect that I haven't mentioned.
Okay, so I'm gonna lower my hand. Okay, and I just like to add a few comments regarding the question of vegetation that Alessandro made.
Yes, definitely. Yeah, just one clarification about the school fix effects.
Okay, so we have a delay there, I guess. So I'm hearing Alessandro making another question.
So guys, I think Alessandro has some drawback. So yeah, I don't know if Ignacio, if you
No. I was saying that yes, you definitely answered the question, and I have just one last clarification on the school fix effects. So basically, can you hear me, Marco? But I have like a delay with Rodrigo speaking about that. I'm not sure I'm able to reply.
We can hear you, though. I don't know if you can hear us.
Can you hear me, Rodrigo?
I think the delay of Alessandro is quite relevant to me.
Okay, I got the problem. I have a lot of delay. Yeah, with a lot of delay, I can hear you, but just to. No, just to close the discussion. My point is that if you control with fixed effect, basically to the extent your confounder doesn't change across years. For instance, if you use year of school fixed effect, you use variation with the school, but you might have something that like people who can sort in a specific school across years or across periods, and in that case, maybe this is not this doesn't allow to fully capture the confounder due to the fact that people choose school based on the level of green or based on school characteristics. So basically that was the point. Okay, thank you.
Okay, I just wanted to make some specific points regarding the vegetation because we do have variation between years, because one of the things that we do is we take satellite image from the closest date of the test. So for example, if the test is taken on, I don't know, October 18, we tried to get the satellite image closest to that date, and we then use we compute an indicator that measured the vegetation cover. We are not measuring green areas, but we are measuring vegetation cover. So it's a different measure. That's why Rodrigo said that we have several discussion about this. And with that, what we are measuring is the specific level of vegetation that students has for that specific season during that specific year. So we do have some variation between years. It's not that much, of course. And the other thing that it's important, and nobody has mentioned this, is that students take the test in the same school that they are studying. So they don't move to other schools. So I think that the effect of vegetation is, of course, not during the test, but probably during the year or accumulated during several years. So what we are measuring with vegetation, I think that is the long-term effect of vegetation, and probably not on the scores, but on the learning. And so we do have some specific things that we can look at closer to try to disentangle the different effects. It's something that we have not discussed with Rodrigo and Esteban, but I think that we could have something there that we can look closer. Okay, that's my point. Thank you.
Okay, thank you very much. There is Andrea Ascani, that is another colleague of us. So Andrea.
Hi, thank you very much, Rodrigo, Ignacio, and Esteban, for your papers, presentation, very interesting. I also had a couple of questions, comments like Alessandro, but differently from Alessandro. I'm not an expert. I don't know this literature very much. And this in a way motivates my first comment. My first comment is that at the end of the presentation, I still kind of struggle a bit to grasp the economic intuition, the reasoning behind the mechanisms that should justify the study of this relationship. I think you had a lot of data to present, and maybe that's why you rushed a bit fast into the data and the methods, but I kind of missed a bit of an elaboration on the economic reasoning and the mechanisms that link pollution and academic outcomes, or vegetation and academic outcomes, or socio-emotional outcomes. In a way, this might be kind of intuitive to some extent, but I really would like to see more elaboration, because this would also justify some methodological choices. For instance, I hear that you have super specific data on the vegetation cover very close to the time of the test, and also the pollution is taken very close to the time of the test. So this would imply a super reaction effect from the pupils with respect to these variables, which makes me think, wow, so there's an increasing pollution and these kids get high and they don't perform well. So but what's behind this? What's the economic reasoning? What's the mechanism behind this? I think this part, at least in the presentation, is missing a bit. I don't know if you want to say something about it. Then another thing that I noticed, which to me looked a bit counterintuitive in most of your tables, is that the fixed effects estimations seem to have much less explanatory power than the OLS when you look at the R squared. The fixed effects estimations have like 10 times smaller R squared than the OLS, which is rather weird to me, because you must be able to control for all sorts of unobserved heterogeneity at the school level that you don't have in the OLS. So I was wondering whether there's specific reason that, because that happens, why that happens. And the last comment is just while you were discussing Alessandro's comments, I thought that you're basically explaining an individual level outcome, which is the academic performance, with some kind of school aggregated variables of interest, because pollution and vegetation varies by school, I guess. Did you try, is it possible to go down to the individual level and estimate the same things at the individual level? That would imply, of course, that you need some kind of individual characteristics. You have to get rid of some ability bias and stuff. Thanks.
So I'll start with the first portion of your question, then I'll send it to Rodrigo. Thank you so much for your questions. Those are really good questions. So what's the logic behind trying to measure the impacts? And I'll focus on vegetation because that's where I personally find a very clear narrative for it. The reason why vegetation is important or could be affecting socio-emotional domain or domains, it's because among other things, there is psychological and physiological restoration. So basically, we have school breaks because you can actually restore your capacity of paying attention afterwards inside of the school. So basically, a school that has a good variety of green areas, and specifically evergreen as we measured, but for example, for instance, if you are attending a high socioeconomic or like a private school that has many more resources, and I know some private schools that have like extended green areas and trees and almost like a forest inside of the school, then your capacity of taking a break and then be absolutely refreshed is completely different than what you could expect if you just have a cement yard in your school. Having that said, the logic behind it is that if you go outside, or if you can actually look outside through the windows and see green, your brain refreshes. And that has been measured in many different ways, in many different situations. There's a very good paper, an Italian paper that I could send to you that also talks about this and measures it in Italy. And we use it also in one of our papers. So that's the basic. That's the basic stuff. Then I would like to add and I don't know if that answers completely, probably just partially. In the pollution case, it's something kind of similar. If you are in a more polluted area, basically you have more issues to breathe, and if you have less oxygen, well, your brain will perform poorly. So it's and that has been measured.
Sorry, but that would be an accumulated effect. You're estimating a level effect that day. Yeah.
Exactly. But at the same time, so here we would jump into a more complicated aspect, which is it okay or is it valid to talk about quality of education, for example, or a measure that happens in one day to measure the performance of a school throughout the year? So the premise of any of those kind of systems is that basically that is an unbiased estimate, right, of the performance of the school. And actually, Chile used them as a school performance metric, not as an individual performance metric. We took it to the individual level because that's where it's nested, and that's where and we could have also more variation. Basically, every student interacts differently, for example, with green areas. Now, because it is aggregated, you're nested, you're in a school, you, in a way, have an average treatment, let's say, of green areas. And in the similar sense, you have an average treatment, academic treatment, let's say. But there is a specific individual experience of those areas that basically, in the aggregate, you could measure the effect. So if we would like to go down and deeper to the individual level and say, oh, this is very individual, and we want to certainly disentangle individuals from their context to measure how they experience those green areas, we would definitely need a completely different design. And basically, I would jump into something that is more qualitative, and which is a phenomenological approach about how people actually experience the world. And that is, and as I said, that's a different kind of question and a different kind of design. Rodrigo, I don't know if you would like to add something to this.
Yeah, I don't know if Ignacio, he has his, no, okay, no, just very, I'll go to some other questions. Thank you, Andrea, for the very also interesting questions. Regarding mechanisms and this reaction to pollution that you said, I think that's very, very interesting and in and of itself. The idea of this, it started with some papers that measured the effects of like fires, for instance, across the field of workers, and then you have some workers affected by the smoke of the fire, and some others that weren't. And those workers were similar in conditions before the fire, but within the day and the next days of that fire, they were outperformed by the workers that were outside the fire area. So then, and there are some papers for China and for the US looking at this. So there is an immediate effect, which we don't think, or at least there is some evidence pointing to that direction. The mechanisms behind that, maybe Ignacio wants to say something about that. We believe are in neurology. We believe are in health reaction. We are not experts on that. We just gather the evidence that we have at hand and then see like, all right, if this is true, then we would be able to find this using pollution in Santiago, which is a very polluted area. So that's basically where we start. But you're right. I mean, probably, and I think I mentioned this, probably the accumulated pollution will have more of an effect. And I said, if you live in a polluted area your whole life, that's going to have more of an effect than if you take a test that day in certain conditions. So yes, that's a very good point. Regarding fixed effects, having less power than the OLS, that's a very good point. Believe it or not, I never paid attention to it. I was just focused on the estimates, on the coefficients of the variables of interest. So I don't have a good explanation for it right now, and I need to think more about it. So I apologize. I haven't thought of that, but I will. And finally, you ask us about the school aggregated data. Yes, that's what we have. We do have some information on individuals. And for that information, it's from a different survey. It's longitudinal survey. So it follows students and families. So that will be more very interesting to use. And we have flirted with that idea of using that database. It has information for like 3 years, 3 waves already. It follows the families, but it's only for very young students, like at this kindergarten levels. What they do there though, it's they take a cognitive test, and they ask where they live and where do they go if they go to the kindergarten or like lower levels of schools. We could do that. There are some other issues there. They answered the name of the place, and the name could be wrong, and the people who typed it could be typing anything, or they could be more than one place with the same name. And so there are some issues there, but yeah, that will be one way to get around what you're saying. So I think, and in fact, again, we have thought of doing that. I don't know if, thank you again, Andrea, for the questions.
Thank you very much.
And I don't know if Ignacio wants to add something. I'm sorry.
Yes, I want to add something, because I think that is the good thing of being a multidisciplinary team, because every part of the team would have different points of view, and I'm mostly focused on. I'm a biologist, so everything in my approach, it's very, very hard in science, and I think that most of the answers here are related with neurology and how the brain works. And in terms of vegetation, I think that we have a lot of information, and there have been a lot of studies and measuring blood levels, different hormones and neurotransmitters. So we have evidence for that. And we also can have an explanation for the accumulated effect of pollution. but really for the short-term effect of pollution at that specific day, it's hard to come up with some good explanation. And I think that we have to think here out of the box. We have to come up with explanations that are not kind of trivial. And maybe this is just an idea, is that Rodrigo mentioned something about the fires, that there have been some studies with fire and smoke. And I don't think that the smoke, the specific level of smoke, is going to have an effect on the oxygen level, and that's why you are going to score, you're going to have a reduced score. But maybe, and this is a kind of weird or very crazy idea, and because we have evolved for several years in the nature and not in the cities, maybe we are when we smell smoke and when we have a certain level of pollution in our brain, then we have a specific reaction to pay attention to other things, not to concentrate in your test, but to concentrate and try to live, try to I don't know, open the window or do other things that maybe are related with your survival in that conditions. Because if there is a smoke, it's because something is there is a fire there, and a fire is very it's a threat for your life. So I don't know. We have to think in different potential options and try to come up with some experiment, work with neurologists, work with other people, and try to bring the knowledge to these specific questions that we have. That's my point of view.
Thank you very much.
Yeah, if I may add something, I think that we are discussing all the time about pupils because the outcome is of the pupils, but sometimes we are neglecting the role of the teachers, because even for the teacher could be a positive outcome. So in the sense that teachers that are in a nice environment, they could teach in a better way because they are much more prone to, I don't know, to be in touch with nature or all the other activities that we already mentioned, so the brain and oxygenation and whatever. And I say something because I also have a paper that try to look at the performance, the educational performance of the pupils. But when I wrote that paper, I also find literature talking about the role of teacher in nice environment, and that was much more related to indoor situation. But this is something that could apply even in this case, and could be also interesting. I don't know if you have data or if Chile collect this kind of data on teachers and the way in which they perform. I don't know if they have evaluation or similar things that you can find. But I think that we can also, if you would like to explain the link or the theoretical link between vegetation or pollution on school performance, there is also the role of the teachers that are much more prone to have better performance. So this is something that I would also have an interesting question, but I think we are running out of time. So I think my colleague already covered a lot of issues. And I don't know, I would leave some space for other questions from the audience if there are anyone. Otherwise, I think we can stop here because we had a lot of discussion on that. Any other questions, comments? No. So, guys, I would really thank you for being with us and for these very great presentations. And we will see in Chile, at least virtually, for the other seminar that I will going to help. So, thank you.
Thanks a lot, Marco, and all the audience, and all the questions. They were really good and make us think a lot. And obviously, we're not coming here trying to say that we have everything solved. So this is very good. And as I was saying, this is an ongoing project. So all this, a lot of the things that you have mentioned, I have marked with the things saying like, oh, this could be a good project. This could be a good paper. So thank you very much. If I can say something, especially about the last thing that you mentioned, Marco, about teachers. Yeah. We haven't even, I don't remember talking about that, Ignacio. And so that is something very interesting that we could discuss and we could add to the mix. Yeah, that's very interesting. At least I didn't thought of that, despite the fact that I also teach. So I should know this. But anyway, so that's very, very interesting. And yeah, we haven't looked into it. So thank you very much for that comment. Please, if you have more comments, send us an email, or
Sure.
if you want to get in touch, either to know more about the papers, the projects, or just like to discuss some ideas. We'll be happy to do that. So thank you very much for the invitation, and we're happy to be here.
Okay, thank you. I will send you some other comments or questions, and just to have a discussion by email. So thank you again for this great presentation, and see you on the next, for the audience here, we will meet to another webinar, and thank you again to everybody. Bye-bye.
Thank you.
Thank you very much.
Thank you, Marco.
Thank you, Marco. Thank you. Bye-bye.